So we're going to be talking about continuity and limits, okay? Continuous functions, how do we know a polynomial, a rational is continuous so that it can help us find the limit. So the idea of continuity may be thought of informally as the idea of being able to draw a graph without lifting one's pencil. So for example, if you draw y is equal to x, you can just go on forever and ever. A graph without breaks, jumps, or holes. So when we talk about the function being continuous at a point, it means that the graph passes through a point without a break. So that means there's no hole, there's no asymptotes, there's no nothing that disturbs it from its natural course. A function f of x is continuous at x is equal to a if its graph at that point is not broken. Okay. So for example, if there's an open circle and then a solid point of a certain number, then it's not continuous. So again, no breaks, holes, or vertical asymptotes at that point. Otherwise, the function f of x is said to be discontinuous at x is equal to a if those conditions do happen to be there. More formally, a function f of x is continuous at x is equal to a if f of a is defined, if the limit as x approaches a exists, if the limit of x approaching a of f of x is equal to f of a, which means all 3 points must be satisfied. Okay, and we're going to prove that later on. So otherwise, if those aren't satisfied, that means that f is discontinuous at x is equal to a, or the limit of x approaching a from the right is not the same as the limit of x approaching a from the left. And if those are different, that means the limit does not exist. And we've seen that already through various examples in Unit 1. So for example, I have given f of x is equal to 1 of x. Let's find the limit as x approaches 0 from the right and from the left. And let's conclude if a limit does exist for this function. So as you guys know, 1 over x looks like this. All right. So again, we have asymptotes at x is equal to 0 and y is equal to 0. So as x approaches 0 from the right, what is our limit of f of x? As it approaches 0 from the right, what is my limit? As it approaches from the right, what is my limit? Yep, as x approaches 0 from the right, it's going to get from positive infinity. As it approaches 0 from the left, what does it get to? Negative infinity. So is there a limit as x approaches 0 in general? No, which means that my limit does not exist because the limit of x approaching 0 from the right is not equal of the limit of x approaching 0 from the left, okay? This is because limit as x approaches 0 from the right of f of x does not equal the limit of x approaching 0 from the left of f of x, which means that it is discontinuous at 0. All right. So far, so good for everybody. Okay, I'm assuming your silence means you guys are good, hopefully. I'm going to get more into some more, we're going to get into a piecewise function. You guys are going to be able to try to pick it up very easily after that. So I have my next one, which is using the graph, evaluate the following limits. All right. So the first one, so looking at the graph, what is my limit as x approaches 4 for f of x? I know it's not exact, but try to give me a whole number. -2. All right. If I evaluate f at 4, what y value should it throw me out? -2 as well. So, is it continuous or discontinuous at f as at x approaches 4? It's continuous. So as x approaches 4, as you can see, this graph is continuous at that specific x value, okay? Doesn't matter about the open circle that's at 2 or the open circle that's at 6. At the point of x is equal to 4, that function is continuous. All right, how about the next one? What is the limit of the function as x approaches positive 2? Okay, thank you, Mohammed. And Maj is going to be 1. However, because of the open circle, that point is not included. If I were to evaluate f at 2, what would my y value be? So basically, what is the dark circle? It's 3. So what would you say about f of x? Continuous or discontinuous at x is equal to 2? It's discontinuous. And why is it discontinuous? What does that open circle tell us at that specific x value? There's a hole. So a hole implies discontinuous. All right. Now, the next one is the limit of x as x approaches 6. Okay? What is the limit of f of x as x approaches 6? Is there one definite answer, or are there going to be 2 different answers for that one? So Priyanshu says doesn't exist. How about everybody else? So remember, let's look at it from the right as it approaches 6 and from the left as it approaches 6. So this is from the left and from the right. Okay, so why would it be does not exist? Why is the answer does not exist for the limit of f of x approaching 6? What is the reason? Exactly. Thank you, Priyanshu. So the limit as x approaches 6 from the right is not equal to the limit as x approaches 6 from the left. So as you can see from the left, it approaches a y value of -3. And from the right, it approaches a y value of +1, which means that the limit from the right is not equal to the limit as it approaches 6 from the left. However, if I evaluate f at x is equal to 6, what would my value be? Which value can I take, -3 or +1? +1. Okay, which means that it is discontinuous. And because of this gap over here between 1 and -3, it is considered to be a break. So there's a break in the function at that specific x value, which means that there is a jump, okay, which implies discontinuity. Okay. Now let's look at the limit as x approaches 0. What would the limit be as x approaches 0? Positive infinity. Now, if I were to ask you guys to tell me the y value of f at 0, what would it be? It would be undefined, okay? The reason why it's undefined is because there is what at x is equal to 0. There is an asymptote, okay? So f of x is continuous at x is equal to 0. Because there is an asymptote. So because there's an asymptote, you can't really evaluate a number. You can't really get a value back at that specific x point. Okay. So, is everyone good with this so far? Is this the easiest lesson that is in Unit 1 or no? Oh, you don't find, oh, this is not the easiest lesson? Okay, fair enough, fair enough. This one involves more of looking at the graph and finding if it's continuous or discontinuous at certain x values. All right, so now we're going to find one-sided limits of a piecewise function. So we have given f of x such that negative x plus 4, where x is less than 2, and negative 2x plus 6, where x is greater than 2. We want to find the limit of f of x as x approaches 2. So what is it that we have to do in this case? What do you guys think we have to do? So we have two functions, so it's a piecewise function, and we have to figure out if there is a limit at x approaches 2 for this function. We're going to find the limit from the left and to the right. Thank you, Mohammed. So we're going to find the limit. Oh, this is the ugly line. It's the fat line. So we're going to find the limit as x approaches 2 from the right of f of x, which means we're finding the limit as x approaches 2 from the right. Which one are we going to use? Negative 2x plus 6 or negative x plus 4? Which one would we be finding the limit of 2 to the right? Negative 2x plus 6, thank you. And the reason being is because negative 2x plus 6 is for all x values bigger than 2, which means that if we approach it from the right, we will be able to find the limit of negative 2x plus 6. Okay? So I'm just going to draw it roughly. So negative 2x plus 6 would look something like this. My bad, that is wrong. We're supposed to go based off of the definition. So we have our value of 2 over here. So we're really only looking at this function going this way. I probably didn't draw it right, that's okay. But as you can see, as we approach it from the right, we can determine a limit for it. So because there's no denominator, I can automatically sub in my 2. So we get negative 2 times 2 plus 6. So what is my limit as x approaches 2 from the right? 2. Perfect. Now I can determine my limit as x approaches 2 from the left of f of x, which means that I'm finding the limit as x approaches 2 from the left of negative x plus 4, which means I can just sub in 2 again. So we get negative 2 plus 4, which gives me positive 2. So what would my limit be as f of x approaches 2? What would it equal? So now that we found the limit from x approaching to the right and to the left, what is my limit as a whole? Remember, because they are the same, that means my limit as x approaches 2 does exist, and that limit is 2. Okay, is everybody okay with this? Any questions? Don't worry, we have one more example like this after this. Okay, so if there's no answer, I'm assuming everyone's okay. So we'll move on to the final 2 examples. Okay, so we want to show that the limit of x approaching 0 of the function absolute value of x is equal to 0. Remember that the absolute value function has, or it looks like a b. Okay, so obviously, from what you guys can see visually, is limit as x approaches 0 of absolute value of x equal to 0. Is that true or not, just by visually seeing it? Would you guys agree with that limit statement? I have one yes. How about everybody else in the class? Do you agree that the limit of x approaching 0 of the absolute value of x is equal to 0 based off the graph that we drew? Okay. As you can see, as it approaches to the right and from the left, it is going to hit 0. However, if I were to ask you to show it based off of limits, how can we write the absolute value of x in terms of a piecewise function? Let's see if someone can figure it out. Thank you. X and negative x. Thank you. So it can be written as negative x, where x is less than 0, which means that we can evaluate our limit from 0 to the left. And then we have x, where x is greater than or equal to 0. And these are x's, and we can approach 0 from the right. So we have to evaluate the limit of x approaching 0 of negative x and the limit of x approaching 0 of x, okay? So the absolute value of x, that function is just a combination of y is equal to negative x and y is equal to positive x. So let's find the limit as x approaches 0 from the left of negative x, which means that we get negative 0, which is just 0. And then we can find the limit as x approaches 0 from the right of x, which is just equal to 0. So because of our limit property, if the limits of the right and from the left are equal, that means that the limit of the root of x as x approaches 0 does exist. So all you're really doing for limits is if you're given a graph or just a function in general or a polynomial function, and you're given a certain point to look at, try to figure out if the limit from as x approaches it from that specific x value from the right is the same as the limit as x approaches that x value from the left. Okay, that's all this unit is about. Okay. So what you guys can do for the next 10 minutes before break is you guys can do example 4, A, B, C, D, and E on your own. Okay? So try to figure those out on your own. And then at 7:30 we will take a break.